It's not zero, it's not none, it's a specific thing.
Undefined.
Yeah, undefined. So we're not going to work with vertical lines, but those are all great examples of parallel lines. Lanes on a highway, lines on a binder paper, all that good stuff. So parallel lines have the same slope, but a different y-intercept. Okay, if we take a look at these two lines, I've got one y-intercept right here, one right there, but these lines have the same exact slope, the same rise over run, the same rise over run. Are these two lines ever going to intersect each other?
No.
No. That's a key feature of parallel lines. They're never going to cross, right? So, if we're going to write an equation, here's what the work's going to look like. We're going to write an equation for a line parallel to y equals 2x plus 3 that goes through the point -1, 6. Okay. Just like in all the problems we were reviewing earlier, what's the first thing that we need to do? Find the what? The slope. We got to know the slope. Okay, I can't stress that enough. We got to know the slope. What is the slope of this line here? 2. So I know that my m is equal to 2. Now, does this line here go through this point, -1, 6? How would we be able to figure that out?
You can plug in x and y.
Plug in x and y. 6 equals -2 plus 3. Was -2 plus 3 6? No, -2 plus 3 is 1. So this line does not go through this point. We have to write an equation for a line with the same slope as this line that goes through this point here. So we know what the slope of my new line has to be because parallel lines have the same slope. That part's easy. But what can I do now, you think, to figure out what my b is? Yeah.
You can. I'm sorry.
No, you're good. What can we do? What did we just do to figure out if this was on the line? We plugged it in. Yeah, thank you, Kristen. We plug it in. So y is equal to mx plus b turns into, I'll make this colorful so we can understand what I'm talking about, hopefully. 6 equals 2 times -1 plus b. Okay, it's just like our solving for b lesson, because that's what we're doing. We're solving for b. What is 2 times -1? -2. How can I get b all by itself now? Plus 2 on both sides. And what is 6 plus 2?
8.
8. So this new line that we have to write an equation for has the same slope of 2, but it has a different y-intercept of 8. Well, how can I write the equation of a line with a slope of 2 and a y-intercept of 8? Liana?
Y equals 2x plus 8.
Beautiful. Just like that. Y is equal to 2x plus 8. So our original line and our new line are parallel. They have the same slope, but they have a different y-intercept. That's exactly the definition that we wrote up here. Same slope, different y-intercept. real quick, let's take a look at these lines. Okay, my original line looked like this. Y is equal to 2x plus 3. Where did my 2x go? 2x plus 3. So there's my original line. The line that we just wrote an equation for, y is equal to 2x plus 8. Do those two look like parallel lines?
Yes.
Yeah. Does that blue line go through my point -1, 6?
No.
Yes, it does. Look right there. It's kind of hard to zoom in, but yeah. -1, 6, right there.
Says it in the-
So these are parallel, yeah. So I put in the green point, it goes through that line, everything looks good. Okay? How are we feeling about that? Quick show of thumbs. Does that kind of make sense? Okay. Important thing to note, parallel lines have the same slope. What's the opposite of a parallel line? Perpendicular lines. Perpendicular lines. Sound it out. Perpendicular. What are you guys doing? Okay, let's put the Chromebook away. Perfect. Even more reason to put it away. Perpendicular lines have inverse reciprocal slopes. A little bit more complicated than just having the same slope. What does a reciprocal mean again?
It's like flip.
Numerator and denominator flipped around, right?
Yeah.
So what would an inverse reciprocal be?
Same thing.
The same thing, but
Different signs.
different sign. Exactly. That's what inverse means, right? Inverse operation, we're doing the opposite sign. If I'm adding, I subtract. If I multiply, I divide. So an inverse reciprocal, just as an example, right? If I had m is equal to 2 over 3, let's say m1. A perpendicular slope to that would be, any ideas? Alex, what do you think?
-3/2.
-3/2. How'd you get -3/2?
Because it's the inverse operation, so it's negative.
Okay.
You also have to do the reciprocal, so flip the bracket.
Good. So you took your original slope, you reciprocated it, so you flipped the top and the bottom. Question, Liana?
I was gonna ask for reciprocal.
Yeah, reciprocal, we flipped the top and the bottom. And then inverse, we made a positive slope negative. What if I had a slope of -4? What would a slope of a perpendicular line to that be? Think about it for a second. 4 is a good start. 1 over 4. That's right.
Let's go.
Positive 1 over 4. What's my denominator here on this 4? 1. So if I flip the 4 and the 1, now the 1's on top. What's the inverse of a negative?
Positive.
A positive. Is that making a little sense? That's probably the hardest part of our notes today. So if that makes sense, you're in good shape. Okay, just to make sure, if I had 2, what would my perpendicular slope to 2 be? Can I get a volunteer to help me out? 2, Anthony?
Would it be? Wait, you said the what?
If my first slope is 2, what's the perpendicular slope to that?
-4.5.
-1/2.
Oh.
Yeah, because we flip the 2 and the 1 and make a negative. Yeah, great job. What if I had -1/3? What would my reciprocal slope, Christian, be to that? Positive 3. What if I had
Wait.
1?
Negative.
Tyler? -1, right? Because 1 over 1 is just 1. Question?
Why wouldn't the 3 be positive 3 over 1?
It is. We just don't need the over 1.
Oh, yeah.
Just like here, 2 is 2 over 1. We don't need that.
Because
Yeah.
because when we put the x and the x shows up as 1, we never.
Exactly, yeah. If I have 1x, I don't need that 1 in front. That's right.
Okay, that makes sense.
Good. I'm glad. I think we get it. Hopefully we get it. That's fine.
Are we done with
No.
that? We have like 3 more pages.
No, I don't think it'll be that much. I'm going to flip pages because I'm going to run out of space. So now we're going to write an equation. For a line perpendicular to, why is it all crooked? There we go. Write an equation for a line perpendicular to let's go y equals -1/2 x plus 4. That goes through the points three, 1. Okay. Looks like most of us are done writing. So, what's my slope for the current line I'm dealing with? What's my slope? -1/2. What would my perpendicular slope to that be? +2. Thank you, Colby. +2. And everybody else? +2. First thing we want to do, figure out the slope. Okay? Now what do we need to figure out?
The B, the y-intercept.
The y-intercept, the b. Okay? So I'm going to take, let's see, what colors did I use? Teal and orange. I'm going to take my x. I'm going to take my y. And I'm going to take my m. I'm going to write out my slope-intercept form. And I'm going to turn that into, what am I going to plug in for y? 1. What am I going to plug in for m? 2. What am I going to plug in for x? 3. And what am I going to plug in for b? B, that's right. Tried to trick you there, but no, you got it. B is just b.
So that means we're solving for b.
That's right.
Yeah.
If we want to write an equation, right, it's telling me to write an equation. I need my m and I need my b.
So does that mean, wouldn't the first step be subtract both sides by b?
Well, we're going to leave b where it's at.
Oh.
What can I do with this 2 and this 3?
Oh, distribute it.
No, multiply.
Yeah,
Oh.
technically, yeah. What if I distribute the 2 to the 3? What's 2 times 3? 6. Yeah, you're not wrong. It is distribution. What do I do with that 6 now? Now I subtract it. I want to get everything away from my b. So I'm going to subtract 6.
Which means -5.
There you go.
-5 equals b.
Perfect. So my m is 2. My b is -5. What's this equation going to look like?
Y
Y,
equals 2x minus 5.
just like that. Yeah,
Yeah.
that's an equation perpendicular to this line through the point 3, 1. But again, let's verify it. Obviously, this isn't something you'll have to do. Let's take a look real quick, and then I'll go back to the notes if you're so right. So my initial line was y equals negative 1/2 x plus 4. Okay. I want to go through the point 3, 1, which is right there, and I need to be perpendicular to that purple line. I'm going to move it up here. The new equation we came up with was y equals 2x minus 5. Does that red line go through the dot?
Yes.
Yeah. Is it perpendicular to my purple line?
Yeah.
How can I tell?
Because it's going straight through the line.
It goes straight through it. And it makes what type of angle right here?
A 90-degree angle.
90-degree angle.
Right.
Do perpendicular lines have to have a 90-degree angle?
That's right. Always.
Oh, they do? I thought they
Yeah.
had like different types of like
I thought they could have different angles.
obtuse and acute. Like,
No, perpendicular means,
Crossing
wait,
at a 90 degree
you're saying like, if I have something like this?
Yeah, like
Yeah, those aren't perpendicular. Those are just intersecting lines.
Like-
Perpendicular is a specific type where we form 4 right angles.
Yeah, because like what I thought perpendicular was like if you do y equals 2 or something like that, or like y equals 1.
Mm-hmm.
That's what I thought.
Yeah. Y equals 1. Yeah, what line would be perpendicular to y equals 1? X equals literally anything. 3, 4, 5, 6, 7, 8. They're all perpendicular.
yeah, it
X equals to infinite.
because it's like
We're getting a little. Let's. We still got more notes to take, so we'll talk about all that stuff later. Okay. Are we good on the perpendicular now? Yeah.
yes.
Okay. One last thing we're going to talk about. Are the two lines below parallel, perpendicular, or neither? Are they just two lines?
Center of
What?
What are you trying to ask? Like, is something going to be like this?
It's that question mark
I need to take on Davis.
Okay. Let's take a look at a couple lines. Okay, let's say we got 3x plus 5y equals 10, and 5x minus 3y equals negative 6. Right away, what do we notice about those two equations? They're in standard form. So what's my slope of this first line?
negative 3 over 5.
No.
Good, I'm glad that you could do that in your head. We can't tell just by looking at it what the slope is, though, right? But that's great. If you can do it in your head, that puts you a little bit ahead. That's great. How would I be able to figure out what the slope of that line is? What would I have to do with my standard form equation?
No, turn it into the slope.
Yeah, we got to put it in slope-intercept form. This is the only form, really, where we can tell what the m is. This is going to be too messy. So we'll just put it in slope-intercept form. This is something we've already taken notes on, right? What's the first thing I want to do here to put this in slope-intercept form?
Subtract 3x
Subtract 3x.
on both sides.
I'm not going to write it underneath the 10 so I don't combine them. And I get 5y equals negative 3x plus 10. I'm going to flip my terms around. And then I'm going to do what?
Divide by 5.
Divide by 5. I'm going to do it all the way across. And I get y is equal to just like Aldrich said, negative 3 over 5x plus, what's 10 over 5? 2. Okay, work out the second equation. Put it in slope-intercept form and see if you can answer the question, are these two lines parallel, perpendicular, or not?
Yeah. It would be. How would it be? Would it be? Actually, wait. Minus 5x, minus 5x, negative 5x, minus 6, negative 3y. Actually, wait, it's neater. It's neater. Yeah, this is neater. No, it's not. It's not neater.
Is that what you guys got for your second equation?
No, it's perpendicular.
Yeah?
No, it's
Okay, so my first slope here is negative 3/5. What's my second slope? 5 over 3. Did I invert my fraction?
Yeah.
Yeah, it went from negative to positive. Did I flip the top and the bottom?
Yes.
Yeah. The 5 went up, the 3 went down. Is M2 an inverse reciprocal slope of M1?
Yeah.
Yeah. So what type of lines do we have?
Parallel.
Perpendicular. Parallel have the same slope. Parallel lines have the same slope. Perpendicular lines have an inverse. Yeah. Okay. Do I have to show all my work on my homework?
Yeah.
Yes, obviously. Right? I took points off your quizzes for some of you not showing your work. So if that's not sign enough that you need to show your work, I don't know what is.
Like the whole problem?
No, just a point. It's only 20 points though. So every point is 5%. So you didn't show your work. That takes you from an 80 to a 75. It's not worth it. Just show your work. If you know how to do it and you got the right answer, you should be able to show the work without issue.